Okay, so in any case, those soothing tones and that rabble means that we're ready to get started. If you don't know me, my name is Nick Anderson. I'm a native plant gardener and advocate, and I've been doing some work with the Rockport Garden Club on the native plantings at Millbrook Meadow. And I've just recently been informed that I'm the newest member of the Rockport Garden Club. And I suppose I should assume that all tech-challenged new members are made to run Zoom meetings as some sort of cruel hazing ritual. But kidding aside, it's a great honor both to be a member of the club and to have a and to have the opportunity to introduce Doug Tallamy, who has greatly influenced my thinking in myriad ways. But I do ask for your patience if I hit any snags with the Zoom interface. Thanks. And now, just in terms of housekeeping, participants can use the chat feature to ask questions during the talk, and then I will read and then I will read off those questions at the end as time allows. So jumping in, Doug Tallamy is the T.A. Baker Professor of Agriculture in the Department of Entomology and Wildlife Ecology at the University of Delaware, where he has published 104 research papers and has taught insect-related courses for over 40 years. His research seeks to better understand the many ways insects interact with plants and how such interactions determine the diversity of animal communities. His book, Bringing Nature Home, published by Timber Press in 2007, was awarded the 2008 Silver Medal by the Garden Writers Association. His other books include The Living Landscape with Rick Dark, published in 2014, Nature's Best Hope, a New York Times bestseller from 2020, and his latest book, The Nature of Oaks, was released by Timber Press this year. Among his other awards are the Garden Club of America Margaret Douglas Medal for Conservation and the Tom Dodd Jr. Award of Excellence, the 2018 American Horticulture Society's B.Y. Morrison Communication Award, and the 2019 Cynthia Westcott Scientific Writing Award. In his written work and in his advocacy, Doug models vital environmental activism, one rooted in curiosity one rooted in curiosity and a new set of possibilities for land stewardship. Bringing Nature Home was life-changing for me, as I came to see that digging and planting in the dirt could represent a much deeper and more satisfying experience than simply making a pretty garden for its own sake. Doug is a writer of rare talent who inspires by showing, who answers questions we didn't know we had, such as why do acorns have those tiny holes in them? Or why do the shapes of oak leaves vary so much? Not only does he answer and explain these phenomena, but he also reveals the answer. Why the answers matter, and moreover, how our understanding of nature can lead us to take better care of our planet in the face of the current climate emergency. In other words, rather than cataloging a set of natural curiosities, Doug's work illuminates the tapestry of the non-human world and how it intersects with human history. He shows how the choices we make regarding our land can help enable survival for all species, including our own. He is a leader in the national conversation at the intersections of ecology, land management, horticulture, and environmentalism. We're so fortunate to have him speaking with us tonight. And so with that, I will turn things over to Doug.
Well, gee, thanks very much, Nick. You worked way too hard on that introduction, but I wish my high school English teachers could hear you say, I have rare writing talent, because they might challenge that. All right, two things before I get started. First of all, if you're wondering whether you can make a beautiful garden out of native plants, go see Nick's work. He sent me some pictures today that will make you a believer right away. Another thing that you should know is there's a thunderstorm right outside my window, which is getting closer every minute. And if I should disappear, It's not because I don't love you all. It's because I've lost my Wi-Fi, and that will be that. But so far, so good. All right, we'll get started. Try to beat the thunderstorm. I want to tell you today about my ideas for what nature's best hope is. But before I do that, I want to return to what happened in 2019 up and down the East Coast. Pretty sure it was up your way as well. We have what we call an oak mast, where all the members of the red oak group, in this case, got together and decided to make their acorns at the same time. And this is what it looked like in a lot of places. I'm easily entertained, so I took one of those acorns and I just stared at it. And I was rewarded because an insect started to chew its way out of the acorn. First, it chewed a little hole for its head, and it forced its head capsule through there. Then it forced its entire body through the same hole. It was a tight squeeze, looked like the Pillsbury Doughboy. Finally, it plopped down. Very dangerous time for this insect larva because it is good to eat. A lot of things are after it. So it gets to safety by wiggling and squirming beneath the soil surface in about 30 seconds. And once it's underground, it stretches in all directions and makes a chamber. And within that chamber, it converts itself to a pupa and then stays there for 2 years. After 2 years, comes out as an acorn weevil. That's what an acorn weevil looks like. A lot of people think weevils have big noses because it looks like they do, but that's actually an extension of the head capsule, and the mouth parts are way down at the end of that extension. They take those mouth parts, chew a hole down into the center of the acorn, turn around and lay an egg in that hole, and that's how the larva gets into the acorn. You might wonder why they spend 2 years underground before they come out as an adult. Why don't they come out in 1 year like most insects would? It takes red oak acorns 18 months to complete their development. So if they came out the very next year, there wouldn't be enough acorns. Of course, after the larva has left, this is the hole that Nick was talking about. There is a hole in the acorn. It's a true vacuum. And you know that nature abhors a vacuum. And in this case, she has filled it with 3 species of temnothorax ants. Tiny little ants where the entire colony lives within the holes made by acorn weevils and acorns. And if they find a new hole in a new acorn, they get excited because their old acorn is falling apart. So they tell everybody it is time to move. They grab the larvae, they grab the eggs. The entire colony moves into the new hole in about 30 minutes. Then they post a guard at the entrance here, make sure nobody else comes in. And this is where they'll live for the next 2 years until this acorn falls apart. What's my point? My point is that it's just one of literally millions of very specialized interactions between animals and plants that comprise the bulk of nature. This is another one, the relationship between jays and oaks. Jays are the primary disperser of oak acorns. They'll take an acorn and fly up to a mile from the parent tree, and then they tap it below the surface of the soil. And the object is they're going to go back and get that acorn from the wintertime and have something to eat. But for every 4 acorns they bury, they only remember where they buried one of them. So they're actually planting 3 new oak trees for every 4 acorns that they bury. And they can bury up to 4,500 acorns per jay each fall. Another specialized relationship, the relationship between witch hazel and its pollinators. You know, witch hazel blooms late in the fall. And there are really very few insects around. I've always wondered what is pollinating witch hazel. The books say it's gnats and things. Never seen anything on a witch hazel flower. But if you go out at night, that's when it's happening. There are a group of moths called winter moths that fly very late. This is a bicolored sallow. I caught it on Christmas Eve, just to give you an example. And it turns out that winter moths are the primary pollinators of witch hazels. Another specialized relationship between pileated woodpeckers and carpenter ants. That is what they rear their young on, carpenter ants. So you won't have pileated woodpeckers unless you have carpenter ants, and you won't have carpenter ants unless you have the big trees that make those carpenter ants. You won't have this bee, Andrena facilii, unless you have this plant, Facilia. That is the only pollen that bee can rear its young on. And it turns out that pollen specialization like this is very common in our native bees. We have a little bit over 4,000 species of native bees, and more than a third of them are highly specialized on the pollens of particular plants. So for example, in New England, there are at least 13 species of bees that can only reproduce on the pollen of perennial sunflowers. You won't have Baltimore checker spots unless you have white turtlehead. I could talk all night, all day, all week about these specialized relationships between animals and plants. The point I want to make tonight, though, is that these relationships, nature itself is on the ropes. And it's on the ropes because we did not take Teddy Roosevelt's advice. Way back in 1908, Teddy found out that the state of Arizona was going to mine the Grand Canyon. So he went to the canyon, stood on the edge, and he said, leave it as it is. And with those 5 words, he started the process of creating the Grand Canyon National Park. It's a good idea, but it's not possible these days because we have not left things as they were. There's only about 5% of the lower 48 states that's anything close to its original pristine ecological condition. And that's because we have logged the country repeatedly. We have tilled it. We have drained it. We have grazed it. Got 770 million acres of rangeland in this country. That's 4.5 times the size of Texas, dedicated to cattle. And of course, we paved it or otherwise developed it. We have straightened our rivers and dammed them, and you can spell that any way you want. We have polluted our skies and changed our climate for centuries to come. We have drained our aquifers. We have introduced more than 3,300 species of plants from other continents, many of which are running amok in our natural areas. In short, we've carved up those natural areas into tiny remnants of their former selves, and each one of those remnants is too small and too isolated from other remnants to sustain the species that run the ecosystems that we all depend on. And you might wonder why we've done all that. I don't know. I suspect we thought that the Earth, our nest, was so big we could foul it forever and there wouldn't be any consequences. Of course, we were drastically wrong about that, and that's why we're seeing headlines like this. The insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about global insect decline. Followed by this one, North America's lost 3 billion breeding birds in the last 50 years. That's almost 1/3 of our North American bird population, already gone. And the UN says, oh, we're going to lose 1 million species to extinction probably in the next 20 years. And I love the way they report headlines like this, as if it's an option. And you might as well say, you're going to lose oxygen in the next 20 years and then go on to the next headline as if it doesn't matter. Losing 1 million species is not an option. It's not something that we humans can allow to happen if we want to remain happy on this planet. So I go on talking about the pox that we have inflicted upon the environment, that's upon all of our houses, but that's not what this talk is about. This talk is about a cure for that pox. It's a cure that'll take small efforts from a lot of people, but those efforts will deliver enormous physical, psychological, and environmental benefits to everybody. Let's return briefly to this headline. The insect apocalypse is here. What does it mean for the rest of life on Earth? Well, great E.O. Wilson, you know E.O. up there in Harvard land. He's a Harvard emeritus at this point, just turned 92 in July. He told us, most famous entomologist of all time, no, hands down, but he told us what would happen to planet Earth if we were to lose insects. And he did it in a paper way back in 1987 called The Little Things That Run the World. And his message was very clear. Life as we know it depends on insects. And if they were to disappear, so would most of our flowering plants. And if most of our flowering plants disappeared, that would so drastically change energy flow through our terrestrial ecosystems that the food webs that support our animals, the amphibians, the reptiles, the birds, the mammals, and even many of our freshwater fishes, those food webs would collapse and those animals would disappear. The biosphere, the living portion of the Earth, would rot because we would have lost insect decomposers that rapidly turn over nutrients today. And all we would have is bacteria and fungi. And of course, humans wouldn't survive any of those drastic changes. The good news is that doesn't have to happen. We can save our insects, we can save our birds, we can save nature itself, but we're going to have to change the way we landscape in order to do it. Why is that? Well, remember, humans are products of nature. We are totally dependent on the life support systems that come from ecosystems. We call them ecosystem services. Here are just a few things that plants do for us and everything else, by the way. Produce oxygen, pretty important. Clean water, equally important. Carbon capture, enormously important in today's world, pulling carbon dioxide out of the atmosphere and taking the carbon out of that molecule and building their tissues out of it. And then pumping the extra carbon that they pull out through photosynthesis into the ground through their roots. Our soils are brown or black because of carbon that plant roots have deposited there over the eons. And of course, once it's in the soil, it's extremely stable. Carbon can stay there for thousands of years. Plants are building topsoil, holding it in place. They're preventing floods, dampening severe weather, converting sunlight to food. And if we lose our plants, we're going to have to eat sunlight. That'll be tricky. What do animals do for plants? They provide pest control services. They pollinate nearly 90% of our flowering plants. They disperse plant seeds. So developing or designing landscapes like this that destroy the production of ecosystem services, not a good idea. Never was a good idea, but today it's an absolutely terrible idea because we need more ecosystem services today just to support humans, let alone everything else, because we got more humans than ever before. We got 7.8, 7.9 billion humans on the planet. This is not the time to take huge portions out of the earth, out of production, out of healthy ecosystem production for a status symbol like lawn. Now, there have been visionaries through the ages who have recognized that we humans needed to work on our relationship with planet Earth. Now, Aldo Leopold was one of the most eloquent. He wrote extensively in the first half of the 1900s. One of the things he said is the oldest task in human history is to live in a piece of land without spoiling it. Now, there have been indigenous groups who've been pretty good at doing that, but our huge Western societies and our huge Asian societies are terrible at doing that. We habitually take more from the earth than it has to offer, completely wrecking an area, then going to another area and doing the same thing. Clearly not sustainable behavior. So Allah had a dream. He dreamt that we humans were actually capable of developing a land ethic. I call it a dream. Maybe it was a warning. We better develop a land ethic. He knew we had to use the earth. We have to farm, lumber, and graze and mine. But he really believed that we are capable of learning how to do those things gently enough that we do not destroy local ecosystems. And that's what he called a land ethic. He wrote about it in the Sand County Almanac. What he did not write about was developing a land ethic where we actually lived. And I'm not sure why that was, but I suspect the notion that humans and nature cannot actually coexist together in the same place at the same time. That notion was so deeply embedded in the culture of Aldo Leopold's day, still embedded in our own culture today, that he may not have recognized it as an option. What I want to argue this evening is that not only is living with nature an option, it is now the only viable option that's left to us. Of course, in the past, conservationists worked pretty much exclusively where there weren't a lot of people. We now need to turn that on its head. We need to save nature, actually reconstruct it where we've already dismantled it, where there are a lot of people, because that's pretty much everywhere. In other words, we have to find ways for nature to thrive in human-dominated landscapes, not hang on by a thread, not get diminished every single year, but thrive. Where should we start? Let's go back to private property. Why? Because most of the land's privately owned. 85.6% of the US east of the Mississippi is privately owned. 78% of the entire country is privately owned. If we don't do conservation on private property, we're going to fail. We're going to fail big time because we'll be working in areas that are too small and too isolated in order to sustain the species and the ecosystem function that supports us. There are a number of conservation options, low-hanging fruit that we're not taking advantage of right now, like power and pipeline rights of ways. We've got 21 million acres in those types of landscapes. 1 million acres is 1.5 times the size of Rhode Island. So we're talking about a big area here. Railroad rights of ways, 3 million acres. Golf courses, 2 million acres. Golf courses, 2 million acres. Airports, 3 million acres. The Denver airport is twice the size of Manhattan. It's big places. 17 million acres of roadsides that are out there. And then we have all the places where we live, both in rural areas, suburbs, cities, hundreds of millions of acres in those landscapes. And none of those are we doing a great job in conservation. We could be. If you add them up, that's 599 million acres. How big is 599 million acres? It's big. It's bigger than Vermont, plus New Jersey, plus Maine, Virginia, New York, Georgia, Florida, Oklahoma, Montana, plus California and Texas. Not having a place to do conservation is not the issue. We can do conservation almost anywhere. Now, when I talk about conservation, I'm not using the term correctly. I'm not talking about conserving the parts of nature that we haven't already wrecked. We certainly want to do that. But I'm talking about putting it back together again in the places where we have wrecked it. It's not true restoration because people will say, well, you'll never restore it to exactly what it was, which is a moving target anyway. And I agree. And we've changed too many things from the soil on up, but that doesn't mean we can't reunite enough of these specialized interactions that comprise the bulk of nature so that you have functioning ecosystems again, even if it's not exactly what was there a couple hundred years ago. But in order to do that, we have to start with the building blocks, the most important groups that comprise the bulk of nature. Not all species contribute to ecosystem function equally. And two of the most important groups include the flowering plants that are, through photosynthesis, capturing energy from the sun, turning it into food, and then storing that food in their tissues. So we need the plants and we need the pollinators that allow those plants to reproduce. Now we have the energy from the sun stored in plant parts, mostly leaves. How are we going to get that energy to the animals? Most vertebrates do not eat plants. They eat invertebrates that have eaten plants. Those invertebrates, most of them are insects. And it turns out that caterpillars are transferring more energy from plants to other animals than any other type of plant eater. So if we design landscapes that don't contain a lot of caterpillars, we've got failed food webs. So, it's easy to measure ecosystem function, measure the amount of caterpillar action that you have in an area. Here's an example using Carolina chickadees. You've got black-capped chickadee up there, practically the same bird doing the same thing. Very common at our feeders all winter, eating seed, and people think, well, that's what they need. 50% of their diet in the wintertime is seed. The other 50% is insects, believe it or not. But when they're reproducing, their babies can't eat seeds. And that's true for most birds. Most baby birds cannot eat seeds, so they switch to insects. And if they're in a healthy environment, they will rear their young exclusively on caterpillars. And it turns out that chickadees aren't exceptions. 96% of our terrestrial bird are rearing their young on insects, and most of those insects are caterpillars. How do I know that? There's a number of lines of evidence that suggest that, but this is a citizen science project that one of my grad students, Ashley Kennedy, did a few years ago at this point. She put out a call to bird photographers to take pictures of bird during the breeding season when they were carrying food to the nest, and then send those pictures to Ashley. She's going to identify the prey items in the beak and reconstruct the nestling diets for as many bird species in this country as she could. And here are some of her results. The green bars for each one of these common bird families are the percentage of the nestling diet that is caterpillars. And in 16 out of the 20 common bird families, caterpillars are dominating the diet of the nestlings. So imagine what would happen to breeding bird success if we took caterpillars out of our landscapes. Most of our birds would not be able to breed successfully. So there's something special about caterpillars. What is it? There's actually several things special about caterpillars, and one of them is that they're soft. Think of this guy as if he's a little sausage with a very thin wrapper. The thin wrapper is its exoskeleton, its cuticle. It's made of chitin, and it's undigestible. So birds don't want a lot of chitin. So, and because they're soft, you can stuff the caterpillar down the throat of your offspring without fear of injuring it. If you've ever watched a parent bird rear their young, they're pretty rough. You take their beak and they just stuff it down there like a plunger. Caterpillars are also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. Many of our smaller birds do chase aphids around, but do you want to chase 200 aphids or get one caterpillar? They're nutritious, they're very high in fat, very high in protein, low percentage of chitin compared to many other insects, particularly beetles. Beetles are not like little sausages, they're like little tanks. So much of a beetle is undigestible. And many beetles have a lot of sharp edges too. And finally, it turns out that caterpillars are the best source of carotenoids for birds during the breeding season. Now, I mentioned carotenoids, not because I love organic chemistry, but because I'm a vertebrate and you're a vertebrate and birds are vertebrates, and we vertebrates cannot make our own carotenoids. Only plants make carotenoids. So we have to get our carotenoids from plants, and we have to get them from plants because carotenoids are essential components of vertebrate diets. And that's why my wife, Cindy, makes sure I have lots of carrots to get my beta carotene, and lots of tomatoes to get my lycopene, lots of whatever that is to get my lutein. And when I eat those things, it stimulates my immune system. And I can't think of a better time to have a healthy immune system. Carotenoids are antioxidants. They run around our body, protect our DNA from oxidative damage. They improve color vision. When your mother said, eat your carrots, you will see better, she was right. She didn't know she was right, but it turns out she was right. Improve sperm vitality, improve sexual attractiveness. Now we're talking about things like this prothonotary warbler male who's had access to lots of luteins. And he takes those luteins and makes pigments out of them, puts them in his feathers, and makes it bright yellow. And the brighter yellow he is, the more ladies he attracts. So that's certainly a good thing. Where does he get his carotenoids from? From the prey that he's eating, of course. But look, carotenoid levels are not equal across bird prey items. These first two bars here are types of caterpillars, far more carotenoids than other types of bird prey. Here are the adult caterpillars. Here are the moths and butterflies themselves, far fewer carotenoids because they're not eating green leaves. That's where the carotenoids are, in the green leaves. And here's the earthworm way down here. So the other bird gets the worm, but he doesn't get any carotenoids when he gets the worm. So that study and others that we've done are suggesting that caterpillars are not optional parts of bird diets. It's really looking like they are essential parts of bird diets. So let's just say birds need caterpillars. The next question is, how many do they need? Is 1 or 2 caterpillars enough, or 1 or 2 caterpillars a day enough? Well, that's a good question. Let's go back to Carolina chickadee. We've got a lot of data on chickadees. How many caterpillars does it take to make a nest of chickadees? Remember, chickadees are seed eaters. How many caterpillars does it take to make a nest of chickadees? 1 or 2 is not enough. 1 or 2 a day is not enough. It takes thousands of caterpillars, 6,000 to 9,000 caterpillars to get 1 clutch of chickadees to the point where they leave the nest. And after they leave the nest, after they fledge, the parents continue to feed them caterpillars another 21 days. But they're flying all around, so nobody's been able to count that. So you're talking about tens of thousands of caterpillars to get 1 clutch of chickadees to maturity. And if you want caterpillars breeding in your yard, and I would think you do, because in so many places, that's all that's left is our yards, you have to have all those caterpillars in your yard, because chickadees only forage about 50 meters from the nest. They're not flying 5 miles down the road to the nearest woodlot. And if we don't landscape in a way that makes all those caterpillars, that's called insect decline. And it's really looking like that's directly related to the bird declines that people are recording. We went to the original data set from Rosenberg et al. They're the group that said we've lost 3 billion birds in the last 50 years. And we divided the terrestrial bird species up into 2 groups. The species that require insects at some part of their life history, mostly when they're breeding, and the species that don't. Things like finches and doves, they can reproduce on seed. They didn't lose any numbers in the last 50 years, but the species that require insects lost on average 10 million individuals per species. This doesn't prove cause and effect, but it certainly does suggest that there is a relationship between declining insects and declining birds. So we need to rethink what our goals for landscaping are. You know, in the past, we've landscaped with one goal, and that is to make pretty landscapes. We thought that plants are just decorations. They are decorations, they're beautiful decorations, but they also have critical ecological values, and creating the food that supports the life around us is one of those. So we need to make beautiful landscapes that also support the insects that run our ecosystem. So how do we add caterpillars, those critical insects, to our landscapes? We do that by adding the plants that support caterpillars, which seems easy enough. But there is a catch, and that is that most plants don't support a lot of caterpillars. So we have to be fussy about it. Fussy about which plants we use, and we have to be fussy about it because the caterpillars themselves are fussy. This is a monarch butterfly, a typical fussy caterpillar. You can have all the crepe myrtle and all the boxwood and all the burning bushes and all the Rosa rugosa, all of the ornamentals from Asia that we typically landscape with. And you won't make a single new monarch butterfly. The only thing that's going to support monarchs is milkweeds. That's called host plant specialization. And it turns out that most insects that eat plants are host plant specialists. Why? Because the plants have made them that way. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense. It keeps most of the insects of the world from eating most of the plants of the world. And that's why it's green out there. It's not because there's no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of those plants. They are too well protected. But insects do eat plants. So how do they do that? How do they get around those chemical defenses? Well, this is where the specialization comes in. 90% of our insects that eat plants are host plant specialists. Every plant lineage that is out there protects itself with a unique cocktail of chemical defenses. And an insect species can't adapt to all of them. So they pick one or two plant lineages that are really similar in how they're protecting themselves. And they develop specialized adaptations to get around those particular defenses. They develop enzymes that store and excrete and detoxify those compounds, behavioral adaptations and life history adaptations that minimize the insect's exposure to those compounds. But it takes a long period of evolutionary history with those plant lineages for all those adaptations to fall into place. And once they do fall into place, the insect is locked into eating that particular plant lineage because it didn't spend any time developing adaptations for other plant lineages. And that's why when you remove milkweed from your yard, you remove monarchs. You remove monarch reproduction. They're not going to start reproducing on your local ginkgo. And that's why when we bring in plants from other continents, and especially when they escape our gardens and run amok in our natural areas, we're destroying local food webs because our insects can't eat those plants. All I'm trying to emphasize here is that plant choice matters. If we're trying to rebuild the food webs around us, we have to choose the right plants because any yellow plant won't work. And I'm going to give you 3 examples of how well this does work when we do choose the right plants. And I'm going to start with our house right here in Oxford, Pennsylvania. This is what it looked like when we moved in. We bought a piece of a farm that was broken up not too long ago. It was a very old farm, farmed almost 300 years. The soil was exhausted. Last thing they did was to mow it for hay. And when you're mowing for hay around here, you're really mowing all the invasive plants from Asia that escape into our quote meadows. So the multiflora rose and the Oriental bittersweet and the autumn olive and the Japanese honeysuckle and on and on and on. You mow that and you call that hay. So of course, when we started to build the house, the mowing stopped. And what do you think came back? We had 10 acres of invasive plants from Asia. That's no way to restore the biodiversity on a piece of property. And of course, that was our goal. So we had to get rid of that stuff. And this is my wife, Cindy, who did that. She cleared our 10 acres. You know, I helped a little bit, but she did the bulk of the work. She sticks with it. So, you know, if you have a serious invasive problem, and a lot of people do, don't give up. Don't think it's impossible. It is not impossible. Cindy did it. Nick has done it. I mean, you can do it. It is a lot of work. There is no doubt about it. But once it's gone, what do? You get to put the plants back. That was my job. I also was telling Cindy she was doing a great job, but and the plants you choose are going to be either good or not good at supporting the caterpillars that run the food web that everything else depends on. So I wanted to attract Canadian owlets to our yard. I'd never even seen a Canadian owlet. That's what the adult looks like. In order to have Canadian owlets, you have to have meadow row. And we didn't have any meadow row. I'm sure it was growing here 300 years ago before the place was farmed to death, but long gone. I don't know of any meadow row around here. So I got some seeds from somebody and I planted them and it grew really nicely. And the question was, can Canadian owlets find my meadow row? And I'll tell you, I doubted it. A little patch of meadow row in the middle of nowhere. Who knew where the nearest Canadian owlets were? So I didn't even go out and check my meadow row for at least 2 months after I planted it. But I was walking by for some other reason and it was covered with Canadian owlets. I had found it right away. Amazing success. I'm still surprised at that. But now we have a good population of meadow root and Canadian owlets. So we've added 2 species to the property. Same story with goldenrod stowaway. It's actually a misnomer. This beautiful moth has nothing to do with goldenrod. It is a specialist on ditch daisy, on Biden's aristosa. Now I did know where there was some ditch daisy in a power line cut about 14 miles away. So I got some seeds, planted them, grew very nicely. Well, it took a year for the moth to find my Biden's aristosa, but it did. And now we've got a good population of both of those. So we've added 4 species to the property now. Wanted the hackberry emperor, not because it's the most beautiful butterfly in the world, but because it belongs here. Well, like its name suggests, it's a specialist on hackberry, and we didn't have any hackberry. So I planted hackberry. I had to wait 4 years for the butterfly to find our hackberry, but it finally did. Last June, I was walking by one of my hackberry trees. And there were 9 hackberry emperor caterpillars on a single branch. So another big success. Now we've added 6 species to the property, and that's how it's gone. I did not plant goldenrod, came in on its own. And along with it came many of the things that require goldenrod, like the beautiful brown-hooded owlet, the Arcigera flower moth, the goldenrod leaf miner, the distinct Sparaginothus, the goldenrod gall moth. This is, curiously enough, this is one that has not come, the goldenrod flower moth. And I'm not sure why it hasn't come. That's what the caterpillars look like. But this is part of the fun. This is the anticipation. It's like waiting for the ketchup to come out of the bottle. Every year I go out and I check my goldenrod looking for these caterpillars. And one of these years I'm going to find them, and that'll be a great day. Planted Virginia creeper. Yes, Virginia creeper. I know people don't like it. I just don't know why they don't like it. It's a highly functional native plant. It can climb our trees without girdling them, without pulling them down, has good fall color. Right now, at least down here, it is in bloom. You wouldn't know it because they're tiny, very tiny little unattractive flowers, but it is a magnet for native bees. There's just this humming all over the place as they're all over those flowers. So it's a great pollinator plant. Those pollinated flowers turn into very nutritious berries that are high in fat for the birds in the fall. And it's, oh, by the way, it's also a good ground cover. It's also the primary host plant for the large sphinx moths that are the primary part of cardinal diets when they're rearing their young. Things like Pandora's sphinx and its beautiful adult, the lettered sphinx, the hog sphinx, abbot sphinx, all on Virginia creeper. I wanted to see if I can get the double-toothed prominent, simply because it's such a cool looking caterpillar. I mean, even if you don't like caterpillars, you got to love this guy. It's a specialist on elm. Of course, we didn't have any elm. The Dutch elm disease took out elm pretty much everywhere, except there's a couple of big elm trees that did not die at the University of Delaware, and they make a lot of seed every year. So 19 years ago, I scooped up some seed from the gutter and planted some at home here. Grew very nicely, germinate in 6 days. You know, by the end of the first year, you've got a tree that's 3 feet tall. Well, they're about 80 feet tall now, big success. And the caterpillar came right away. So, and we're talking about American elm here. Wanted the evening primrose moth because it's beautiful. I like beauty like anybody else. And believe it or not, we had no evening primrose. So I planted that, Enithera. Moth came, it spends the day with its head stuck in the flowers. It's very cute. And I planted lots of oaks. Now, these are just examples of the plants that we put in our yard. But I want to focus on oaks for a while because they're such important plants. This is the Bedford oak in Bedford, New York. Maybe you've seen it. People argue about whether it's 400 years old or 500 years old. It's enormous. And I hear people say, well, I'm not going to plant an oak because I won't live long enough to enjoy it. And if your tree has to be 400 years old before you can enjoy it, you're right, you won't. But if you can enjoy what your oak does, and you're in your ecosystem, you can enjoy it right away. And I can say that with confidence because I planted my oaks as acorns, which means they're free, or 2-foot bare root whips, which means it costs $1.50 each. And immediately they started to rebuild the food web in our house by attracting the moths that run that food web. Things like the solitary oak leaf miner, Juvenil's dusky wing, the yellow-shouldered moth. What is this one? Suzuki's promolactus, beautiful moth. The red-washed caterpillar, the yellow-vested moth. The orange-tufted oneida, the spiny oak caterpillar, the 2-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the orange-humped oakworm, the pink-striped oakworm, the hesitant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crown bucculatrix, the orange-patched smoky moth, the white-blotched heterocampa, the oblique heterocampa, the red-line panapoda, the laugher, and literally hundreds more species of moths have come to the oaks that we put in our property, and they come right away. This is a pin oak that has just popped its head above the leaves, and here's a caterpillar standing on the ground eating that tree. So you don't have to wait hundreds of years for your oaks to start to contribute to your ecosystem. They contribute the very first season that they're in your yard. Now, this is what our yard looks like right now. This is my Zoom room right here, sitting up there. I show you this to convince you that we're traditional. We got a little lawn here, but we put a lot of plants back. And I learned a long time ago that every time I put a new plant lineage into our yard, there's a good chance I will attract the specialist moths that use that plant, enrich the food web that supports everything else in our yard. So 4 years ago, I decided to try to get a picture of every species of moth that is now making a living at our house. I am still at it. And just the other night, I got up to 1,122 species of moths that I've taken pictures of so far. Now we have 10 acres. Pennsylvania is 2.4 million acres. So on 1/240,000th of the land mass, we've got 44% of all the moths that occur in Pennsylvania. And we have them because we put the plants that those moths need back. And because so many of these species are types of bird food, we have recorded 60 species of birds that have bred on our 10 acres, not flew by, but bred. Why am I telling you this? Well, this is another headline that we saw last year. The World Wildlife Fund says that Earth has lost 2/3 of its wildlife since 1970. But I'm thinking, not at our house. I am sure we have increased biodiversity by at least 2/3, probably more than that. And it didn't take nearly that long. And all we had to do was put the plants back. It just wasn't that hard. So don't despair when you see headlines like this. Get motivated, get angry, get out there and start planning. We can turn these things around. But I know what you're thinking. We've got 10 acres and maybe you don't if you live in the suburbs or a city. Will it work on smaller properties? Well, let's go to Margie and Dan Terpster's house in Kirkwood, Missouri, where the major invasive plant that they have in Kirkwood, Missouri is bush honeysuckle, Amur honeysuckle. So when they moved in, the first thing they did was get rid of that. They live on 0.6 acres, so 18 times less land than Cindy and I have. And after they got rid of their bush honeysuckle, they planted lots of natives, put in a water feature they call a bubbler. And then they started to count the birds that are using their yard. They're up to 149 bird species, 35 warbler species. And just to put that in perspective, we've only recorded 8 warbler species at our house on 0.6 acres. Does it work on smaller properties? Absolutely. How about in urban yards, truly urban yards? Let's go to Pam Carlson's house in Kirkwood in Chicago. Pam's Carlson house in Chicago. And I mean in Chicago, because right on the other side of this wall here is one of the runways of O'Hare Airport. Right over here is Kennedy Expressway. Pam has 1/10 of an acre. That's 3 times smaller than the average lot size in North America. It's a pretty 1/10 of an acre, but it is not connected to any natural area at all. So Pam's a tiny little island. But she did the same thing. She got rid of her invasive plants, put in 60 species of native plants, a water feature for the birds, and then she sat back. She tells me she sits back with a little glass of wine in the afternoon and counts the birds that have used her yard. And she is up to 120 species of birds, including a woodcock. There's Pam's woodcock. If you haven't seen a woodcock lately, go to Pam's house in Chicago, and he's there. What about city centers, though? 82% of us live in cities now. Are they going to miss out on all this fun? Well, in 2014, I was staring at this plant, Asclepias tuberosa. People call it butterfly weed, which reminds me we got a marketing issue with our native plants. We call them weeds and wonder why people don't plant them. So let's not call this butterfly weed anymore. Let's call it Monarch's Delight. Okay, we're staring at Monarch's Delight 2014. The first thing I saw were 2 species of leafcutter bees, megachilid bees, a big one and a little one. I know they're megachilid bees, they're leafcutters because they carry their pollen on their tummy. Well, leafcutter bees have very strict requirements. They're not going to be there unless they have what they need. And not only do they need pollen and nectar, they also need soft leaves. And leaves of redbud are perfect because they carve out, they snip out the edges of those leaves and leave these characteristic little semicircles, then roll them up into a tube, stuff them full of pollen and lay an egg on it. And that's how they reproduce. They stuff that whole package into a crack or a crevice. Well, there was a redbud growing right next to Monarch's Delight. So I'm sure the leafcutters had everything they needed. Of course they were there. Pretty sure that's why there were bumblebees there as well. Bumblebees, of course, overwinter as queens. When they come out in the spring, they've got to do all the work themselves. They've got to start the colony by doing all the foraging for pollen and nectar because there are no workers. And if they don't have access to easy pickings like redbud that's loaded with flowers early in the spring, they're going to fail. Well, there was redbud there. There were bumblebees there. So I'm pretty sure that was the relationship that created that. Then I saw two monarchs on Monarch's Delight. Now, this was 2014. I had gone all of 2013 without seeing a single monarch. That was the low point in the monarch population in the east. Only 3.6% of the monarchs east of the Rockies were around in 2013, compared to 1976. And this was June, so it was very early in the season to be seeing monarchs. It was, it was encouraging. Maybe the monarchs weren't going to disappear after all. Why were they there? Well, they had Monarch's Delight, but there was also another species of milkweed. I think it's purple milkweed, which means the monarchs had everything they needed. They had pollen and nectar, but they also had host plants. They could lay their eggs on these milkweeds and reproduce. Do you know where I was? I was on the High Line in the middle of Manhattan. I was on the High Line, 30 feet above the taxis, right in the middle of lower Manhattan. The High Line, if you don't know, is a renovated, elevated railroad. It had been abandoned for decades. Somebody went up and saw there a whole bunch of native plants growing on their own. Nobody planted them. So they made it a tourist attraction. They built this walkway here, and this is the planting that goes along the High Line. It's about 3 feet wide. There's the Monarch's Delight. This is Rick Dark. He was always after me to go to the High Line and see the beautiful plantings. I'm not much of a city boy, so I always drag my feet. But going and seeing beautiful plants and with nothing using them is actually depressing to me, and that's what I thought I would find on the High Line. I could not imagine that any insect in its right mind would be using anything in the High Line. It's just too isolated. But I was completely wrong. Everything I described to you, I saw in the first 20 minutes. Somebody just finished a study of the native bees using the High Line. They're up to 30 species. There are birds there. So, I changed my mind completely. If thoughtful native plantings, and the High Line's not 100% native either, can attract this much wildlife to the middle of Manhattan, we can succeed just about anywhere. There are 4 things we need to think about, though, if we're going to succeed in a big way. And the first one is we've got to reduce the area we have in lawn. We've got way too much lawn. We've got over 40 million acres of lawn nationwide, which is the size of New England, by the way, dedicated to an ecological dead space. Lawn, of course, is a status symbol. And I understand we humans need our status symbols. We need to tell our neighbors that we are neat. But we can still do that. We can cut the area of lawn in half. And the area of lawn we keep will still be manicured. We can still follow all the cultural rules. But we can replant. If we've got 40 million acres and we replant half of that, that's going to give us 20 million acres that we can put towards conservation. We can create a new national park. And if we do it at home, we can call it Homegrown National Park. And it'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. Add up all those parks, still less than 20 million acres. So Homegrown National Park will be the biggest park in the country. What do we get when we put some part of nature at home? You get the opportunity to develop a personal relationship with that part of nature at your own time, your own pace. All you have to do is go outside. You can avoid crowds. I don't know if you saw the article in the New York Times, maybe yesterday, about all the people in our parks now. I mean, you go there now, there are millions of people there. It's become an issue. It's also free. There's no admission fee. It's never closed, no matter what pandemic comes down the pike. No travel hassles. You get to experience the natural world alone. And I don't know how you develop a personal relationship, you and Mother Nature, if it's mediated by somebody else. This is really important for our kids because our kids are suffering from what Richard Loup calls nature deficit disorder. So we're trying. We get 30 kids, put them on a bus with a teacher. They drive for an hour, walk around a natural area for an hour. The teacher tells them not to touch anything. They get back on the bus and they go home. And I'm sure that's better than nothing. But what they really had an experience with is 30 other kids and the teacher telling them not to touch anything. If there's some part of nature right where they live, they can go outside and discover it, fall in love with it, learn how to be a good steward of it, which is critical because they're the future stewards of our planet. And if they don't love the natural world that they're supposed to be stewarding, they're going to be lousy stewards. Maybe they'll learn how to hunt lizards. I'm learning this from my own granddaughter, Zoe, who lives in Hawaii on a very modest piece of nature. It's a little patch of lawn, about 10 by 10, and a hedge. But there are anole lizards there. And when Zoe discovered that, she sent me this picture to explain how you hunt lizards. You get on the ground and you cover yourself with leaves and sticks so the lizards don't see you coming. And you crawl very slowly toward the lizard. No smiling. This is serious business. You can wear your best dress, that's okay. But you crawl slowly toward the lizard, you catch the lizard, you put it in an aquarium, you learn how to take care of the lizard, and you've got that personal relationship with that piece of the natural world. Now, I don't think Zoe's going to be crawling on the ground in her best dress, catching lizards the rest of her life. I don't think. She sent me this picture the other day, so who knows. But I guarantee she's going to remember catching lizards in Hawaii the rest of her life. And I also guarantee she's going to be a good steward of the planet, in part because of that experience. If you want your kids to do more than catch lizards, get Nancy Stranisti's Nature Play at Home. Give you dozens of examples of how to expose your kids to nature right where they live. And if you want to join Homegrown National Park, go to our new website, homegrownnationalpark.org, and get yourself on the map. Here's the map. What we're trying to do, of course, is build Homegrown National Park, 20 million acres. We want to get people to convert that much lawn into native plantings. So this is it's a social medium attempt to raise awareness, particularly among people who are not part of the choir. They don't know that their piece of the earth is important. We want to motivate people, even if it's through social interactions. And we want to make it easy for them to get started, give them the tools that they need to get started. So that's what Homegrown National Park is all about. Oh, by the way, it is free, and no, we're not using your data. So we're going to shrink the lawn. What plants are we going to put in the area we take out of lawn? I'm going to argue that at least some of them have to be what I'm calling keystone plants. What's a keystone plant? Remember what a keystone is. This is the Roman arch. The keystone is the stone in the middle of the arch. And if you take that stone out, the arch collapses. Well, if you take a keystone plant out of your local food web, the food web collapses because keystone plants are making most of the food. Just 5% of our native plants are making 75% of the caterpillar food that drives those food webs. 14% of our native plants are making 90% of the caterpillar food that drives those food webs, which means 85% of our native plants are contributing, but not all that much. So think of the keystone plants in the ecological house that you're building as the 2x4s that are holding up that house. They're essential. You can't build a house out of wallpaper. They're not the only thing your house is built out of, but they are an essential part of it. So the question is no longer simply, are natives better than non-natives? On average, they certainly are, but there are a whole lot of natives that are not going to make that food web successful if you don't have those keystone species. The question really is, do we want to favor the natives that are going to support the most caterpillars and the most pollinators? There are keystone pollinator plants as well. I get an email once in a while from somebody saying, don't I know that ginkgo biloba from Asia actually grew in North America 7 million years ago? That makes them native. That means we can plant them and everything will be great. Yes, I do know that ginkgos grew in North America 7 million years ago. We can argue about whether that makes them native today, but I'm not going to have that argument because that's not our true metric anymore. It's not whether they're native or not. It's whether they're doing anything or not. I don't care if ginkgos grew on the moon 7 million years ago. They support 0 species of caterpillars today. They are not contributing to the local food web. They're just standing there. What is contributing more than anything else? Well, in 84% of the counties in which they occur in North America, oaks are the #1 keystone plant. In the mid-Atlantic states, they support 557 species of caterpillars, 557 species of bird food, over 950 species nationwide. There's no other plant genus that comes close to that in terms of supporting the life around us. Here's the power of keystone oaks in our yard here in Pennsylvania. Now remember, I've taken pictures of 1,122 moth species. Haven't gotten to the butterflies yet. I will. And out of that 1,122, 978 have known host plants. So the, 120, 130 we don't know what they're eating at this point. Out of the 978, 287 species use oaks. Now, I've got 69 genera of native woody plants on our property, and only one of them is Quercus, the oaks. And we've got hundreds of genera of herbaceous plants. So oaks represent less than 1.5% of our woody plant diversity and way less than 1% of our total plant diversity. But they're supporting 29% of our moss species diversity, and then all of the birds that depend on that. So if we took oaks out of the system, we took that keystone plant away, what would happen to our diversity? Wouldn't be good. How do you find out what the keystone plants are where you live? You go to Native Plant Finder and National Wildlife Federation website, and you put in your zip code and the ranked list of both woody and herbaceous plants for your county, ranked in terms of the number of caterpillar species that they support, will pop up. So here, this is what a typical list looks like. And, I stopped because I ran out of room. Native oaks, native cherries, native willows, blueberries, very high. And then notice I'm saying native, native, native. If I go to the nursery and say, I want to buy a cherry, and I don't specify, they will sell me a flowering cherry from China. If I want to buy a willow, they'll sell me a weeping willow from Turkey. If I want to buy a birch, the chances are good they'll sell me a European birch. Why? Because that's what they have. Maple could be a Japanese maple. You got to specify that you want a native member of these really important keystone genera. Because if you get a non-native member, you've reduced caterpillar use by 65%. These are the really top performing herbaceous perennials. Solidago, goldenrod's very high. There's 110 species of caterpillars on goldenrods. Aster was broken up into several genera. They're very high. Our helianthus sunflowers, particularly the perennials, ranked very high, not just in terms of creating caterpillars, but also in terms of creating specialist bees. When you're creating a pollinator garden, you want to plant for the specialists, the ones that can only use particular plants, because the generalists can use those plants too. If you only plant for the generalists, things like bumblebees and honeybees, you'll lose your specialists because they can't use those plants. So these three genera right here, for example, will support over 44 species of bees in New England if you have them in your yard. If you don't have them in the yard, that's 44 species that you won't have as well. And if you live in Canada, there's a similar website up there that helps you out. So we're going to shrink the lawn. We're going to put in keystone plants. We're going to attract a lot of insects to our yard, and then we're going to kill them with our security light, which of course is not the goal. There's quite a bit of research coming out these days that is convincing.
Yeah, I am.
But we got it. Good. Okay, the research is convincing that light pollution is one of the major causes of insect decline across the world. And these are all the ways that lights are killing our insects at night, particularly those all-important moths. But you know what? This is good news to me. We have to turn around insect declines. We've already lost 45% of the insects on planet Earth. And these are the things that keep us alive, folks. If we can't keep losing them. So if we can increase insect populations by simply flicking a switch, turning off our lights at night, we're getting off easy. That's good news. But I know what you're going to say. I can't turn off the light over my garage because the bad man will come. Okay, put a motion sensor on it. So it only turns on when the bad man does come. And the first thing you're going to recognize is the bad man doesn't come very often. And if you don't want to do that, take out the white bulb from your security light and put in a yellow bulb. A yellow LED bulb is the best because yellow wavelengths are the least attractive to nocturnal insects. If we replaced our white security bulbs with yellow LED bulbs overnight, we would save billions of insects and billions of dollars too, because of course LEDs are much more energy efficient. So we're going to shrink the lawn. We're going to put in keystone plants. We're going to turn out our lights, and then we're going to invite Mosquito Joe to come kill all of our insects. We just love killing insects. This, of course, is a booming business across the country. Mosquito Joe is single-handedly undoing everything I've been talking about for the last 12, 13 years. But he says, well, that's okay because this is a natural product. He's right. It's pyrethroids. It's a natural product, but cyanide is a natural product too. So I'm not sure that's a good argument. He also says, and he's not right about this, that it only kills mosquitoes. That's not even close to true. I don't know if you saw in the headlines last fall during monarch migration, hundreds of monarchs killed when they flew through Mosquito Joe's work, all laying dead on the ground. This kills all the insects it comes in contact with. The really frustrating thing, though, is that mosquito fogging doesn't work. In order to control mosquitoes, you've got to, in the adult stage, you've got to kill 90% of them. That's why you don't try to kill them in the adult stage. It's almost impossible to kill 90% of the mosquitoes. Mosquito Joe kills between 10 and 50% of the mosquitoes. So he's not even close to being functional. And that's why he has to keep coming back. And that's why he has to keep charging you. He's very expensive for something that doesn't work and kills lots of non-targets. If you really want to kill mosquitoes, get a bucket. People say, how big a bucket? Doesn't matter. Bigger the better. Fill it full of water, put in a handful of straw or hay, and let it ferment for a couple of days. You're building up populations of diatoms and algae, and that's what mosquito larvae eat. And this becomes an irresistible brew for female mosquitoes that want to lay their eggs. They'll lay their eggs in your bucket. Then you go to the hardware store and get mosquito dunks. You get a bunch like this for $9. You put a mosquito dunk into the bucket. This is Bacillus thuringiensis. It's a type of Bacillus thuringiensis that is specialized on aquatic diptera. Only kills aquatic diptera. And the only aquatic diptera in your bucket is a mosquito larva. So the mosquito larvae, you chew on it, they die. And if you have a dragonfly larva in here, won't hurt it. If your dog licks it or a bird drinks it, no problem at all. And so you're not killing any non-targets. It's cheap. And if everybody did it, it would work a whole lot better than Mosquito Joe. Fourth thing we need to do is to landscape in a way that allows those precious caterpillars to complete their development. What do I mean by that? Well, I live in Chester County, Pennsylvania, where oaks support 511 species of caterpillars. A few of them, like the polyphemus moth, complete their development on the tree. Here's a caterpillar, eats the leaves, then it spins a cocoon and hangs from one of the branches. Then it emerges as an adult, and then it does it all over again. I wish everything did that, but most species don't. Most species fall from the tree after they finish growing and wiggle their way beneath the ground, pupate underground, or they spin a cocoon in the leaf litter that's under the tree. And that's the problem. There is no leaf litter in the tree, and we mow and compact our soils to the point where they are way too hard for any caterpillar to wiggle their way underneath there. So the way we landscape becomes an ecological trap, and I'm convinced that this is another major cause of insect decline. We call in any adult moth that's surviving, they lay their eggs, the caterpillars develop and drop down and die. And of course, the cement landscape is even less of a viable option. This is what most people do. You have a big tree and a lawn. Nobody's measured how well caterpillars do in a situation like this, although we're starting that project this summer. But I guarantee they're going to do a whole lot better in a situation like this, where you have a tree and then a layered landscape, maybe a native dogwood here, and then native azalea ferns, ground cover. The caterpillar drops down into a safe site. The soil's not compacted. It's not going to get mowed, not going to get stepped on. It can wiggle its way underneath there and pupate, or it can spin a cocoon in the leaf litter. Survivorship will be much higher. This is a great place to do your spring ephemeral gardening. You put a bed around your tree. That's just how you shrink the lawn. Garden around your trees rather than mowing right up to them. All this is safe sites. And of course, it's beautiful. This is where you can use your ground covers liberally, your wild ginger, your mayapple, your foam flower, all those spring ephemerals, ferns. This is a hotel in Athens, Georgia. These are red maple trees. Any caterpillar developing on the trees can drop down into these ferns, complete their development. It's a safe site, even though it's the middle of a city. So we can do a whole lot better with landscaping under our trees if we understand how critical it is to the survivorship of that really important component of our food webs. Another graduate student, Desiree Narango, who's actually doing a postdoc in Massachusetts as we speak, did some great work with chickadees in the suburbs of Washington, D.C. And the results of her study suggest that there's actually room for compromise in our plant choices. What she asked is, How well do landscapes that are dominated by native plants sustain chickadee populations compared to landscapes dominated by introduced plants? And the first thing she found is when the landscape is dominated by introduced plants, they produce 75% fewer caterpillars. So right away, you reduce the amount of bird food by 75%. Those landscapes were 60% less likely to have breeding chickadees at all. There were nest boxes up in everybody's yard, but the chickadees would come and look around and say, well, there's not enough food here. We're not even going to try. If they did try, those nests contained 1.5 fewer eggs. Those clutches were 29% less likely to survive at all. If they did survive, they produced 1.2 fewer fledglings and matured 1.5 days later than the nests that were in native landscapes. If you put all that into a population growth model as a function of the percentage of non-native woody plant biomass in your yard, from none to 100%, this is what you get. We focused on woody plants because that's where chickadees forage. The dotted line is replacement rate. That's the rate at which the population has to make babies in order to replace the adults that die every year. If you reproduce at this rate, it's a sustainable population. It's not growing, but it's not shrinking either. If you reproduce at this rate where you're making more babies than adults die, you have a growing population. But if you make fewer babies, if you're out here with all this high percentage of non-native woodies, you're not making as many babies as adults die. So you have a shrinking, unsustainable population. Right here is where those lines overlap. And generously speaking, it suggests that you can have up to 30% of your woody plants non-native. It can't be invasive. So no Bradford pears, no burning bush, but 30% non-native without destroying the local food web, as long as they're not dominating. If you get more than 30%, so less than 70% native woody plants, that's when you run into trouble. This is exciting to me because this is the area of compromise. You can have your ginkgo, you can have your forsythia, you can have your camellias or anything else that's not invasive that everybody insists on having without destroying your food web, as long as it doesn't dominate your yard. And I think that's important because if my message was you can't have any non-natives, very few people would be listening. Remember, it's not the presence of non-native plants that destroys food webs, it's the absence of native plants. So if we increase the percentage of natives, we will have a lot more, we can tolerate a lot more of these. Can natives be used successfully in formal landscapes? Of course they can. I got this from Lynn O'Shaughnessy, this picture, taken by a drone 400 feet up. That's a big garden, and every plant in that garden is a native plant. Formality is a function of the design. It's not a function of the plants in the design. Our native plants are used in formal designs in Europe all the time, and I guess that's okay because they're non-native plants there. Can we get a pollinator garden into a typical suburban yard like this without offending anybody? Of course we can. Put a little fence around it. It formalizes it. People recognize that it's there on purpose. It's pretty. It's satisfying the needs of a number of bees. Not very big. Could be bigger, but if everybody did it, it certainly would help. This is a Drew Latham design, even bigger. Imagine the amount of life that is here versus the amount of life that is here. Seems like a no-brainer. Can municipalities help us live with nature? Of course they can. And more of them are doing it. Minnesota has a cost-sharing program. It's called the Lawn to Legume program that encourages the state is paying people to reduce or replace their lawn with appropriate Minnesota prairie plants, very popular. Pennsylvania has a new lawn conversion program. So you get up to $5,000 per acre to convert your lawn to natives. Florida, there's an island off of Florida that is paying people to allow burrowing owls to burrow in the front yard. This is the way the Endangered Species Act should have been written, with carrots rather than sticks. The burrowing owl is a listed species. If you have an endangered species on your property, we're going to pay you to take care of it. Everybody would want one. Missouri and Fayetteville, Arkansas had a bounty on calorie pears. You take out a calorie pear, you get a free tree replacement. Even public utilities are getting into the act, giving people $100 coupons in the West to plant water efficient native plants and not the thirsty non-natives. And of course, the very successful lawn replacement programs in far West California that has no water at all. You get up to $2 per square foot to take out that lawn and put in appropriate xeric plantings. I think we made 3 missteps in the early years of conservation, and the first one's a serious one. We've come to think of nature as optional. We don't really need it, not essential. And of course, if it's not essential, when push comes to shove, when resources are in short supply, nature will always take a back seat because we don't really need it. And of course, resources are always in short supply. Went to the Cincinnati Zoo before the virus broke out. And there's this wall-sized poster there, which to me epitomizes our society's view of conservation. We wanted to save wildlife, save nature, so that future generations can enjoy it. And I get that. I mean, that was Teddy Roosevelt's reason for doing the national parks. Save these places so the future generations can enjoy it. He said it over and over again. But to me, that suggests that nature's there just for entertainment. It's much more than entertainment. We need to save nature so that we have future generations. A little bit more urgent. We've also assumed that humans and nature cannot coexist. And we talked about this, but if we restrict conservation just to areas where there are not a lot of humans, we're going to fail because those areas are too small and too isolated from each other to sustain the ecosystem function that we require. David Quammen has this great analogy between a Persian rug and an ecosystem. That is a functional Persian rug. That is not 71 Persian rugs. That is 71 rug fragments, none of which are acting like a Persian rug. And that's what we've done to our ecosystems. The UN designates biosphere reserves as places of ecological significance. And I hate that language because it suggests there are places on planet Earth with no ecological significance. Not so. Every square inch of the planet has ecological significance, including our yards, including our corporate landscapes, including our roadsides, even including our agriculture. So we need to glue our rug back together again, folks, by putting the plants back, favoring those keystone plants, not just to make biological carters that allow plants and animals to move back and forth between viable habitats, but to create viable habitats where we've destroyed them, where we live, where we work, where we play, where we farm. In other words, for the first time in modern history, we're going to actually coexist with nature. Our third misstep was to leave Earth stewardship to a few specialists, a few ecologists, a few conservation biologists. We didn't see it as an inherent responsibility of every human being on the planet. But I don't know why, because every human being on the planet depends entirely on the quality of Earth's ecosystem. So why wouldn't everybody bear the responsibility of good Earth stewardship? Stan Rushworth once said that the Western settler mindset was, I have rights. The mindset of indigenous people is, I have obligations. You're not born with these mindsets, you're taught them. And we've been good at teaching this one. We've been terrible at teaching this one to our kids and to our peers, what your obligation to Earth stewardship really is. It doesn't mean you have to save biodiversity for a living, but you can save it where you live. And if you do, it empowers you. You know, people feel powerless now. What can one person do? The Earth's problems are hard or, terrible. Well, one person can do a lot of things. One person can shrink the lawn. One person can turn out their lights. One person can put in a pollinator garden. One person can use keystone plants. One person can totally revitalize the ecosystem integrity of their property and enhance their local ecosystem instead of degrade it. It also shrinks the problem down to something that's manageable for each one of us. Don't think about the entire planet's problems. You get depressed. Just worry about your piece of the planet that you can influence. If you own property, that's obvious. That's where you start. If you don't own property, help somebody who does. Help a land conservancy, help a park or a preserve. They're all underfunded, understaffed. They'll love you as a volunteer. So as property owners or as volunteers, each one of us has the power, and we certainly have the responsibility to fix dead landscapes like this. Whether or not we decide to do so is going to determine nature's fate and then ultimately our own fate. Now, I think I've convinced my grandchildren that you are nature's best hope. Hope I've convinced you as well. Thanks very much.
That was great. Thank you. Nick, are there any questions?
Thank you so much, Doug. That was absolutely inspiring and incredible. Yeah, we have a few questions coming in. So
They answered?
Can you hear me?
Yeah.
Yep.
The first question we have is, how did Judy take care of the invasives on your property?
Cindy, I didn't
Sorry,
marry
Cindy.
you.
Oh, I apologize.
She enjoys doing it. Okay, it's a long story. She will not use herbicides. She's got asthma and she just won't use them, which means she makes it hard on herself. But she likes it. So she did it by labor, cutting and pulling, and doing it repeatedly. When she has some spare time, she's out. And, we got rid of the major invasives, but the neighbors didn't. So they're always seeding in every year. And 10 acres is a lot of land. So we had to be vigilant. And I'm very fortunate that she enjoys doing it. But hard work is how she did it. But, she did it to the point where the vast majority of the plant biomass on our property is native. It's highly productive. I mean, we wouldn't have those 1,122 species of moss if it was all invasives anymore. So functionally, she has done it. But of course, if we both dropped dead tomorrow and nobody did anything, it would return to invasive very quickly. So what we want to do is have enough people do this so that steady seed rain from everybody else's property would decrease. And eventually we really can get these things under control. I mean, they're not going to disappear. We have to be vigilant. We now have to garden the world because of the way we move plants all around it. But there's a lot of us, so we can do that. We can do that.
Excellent. Another question that came in is, would you repeat the type of bee that you said ate the red leaves? What bee eats the red bud leaves?
Eats the red leaves?
Red bud.
Oh, red bud.
Canadensis. Yeah, sorry.
It's the leafcutter bee. Just uses them to make a package. It's snipping they're soft and pliable. So it snips a little part of the leaf out and rolls it up. They're not actually eating the leaf. They're just using it as a package, but they need those very soft leaves to do that. Leafcutter bees.
Excellent. Thank you. Another question that came in, this is from Lucas O'Neill. It says, my father is pretty adamant about spraying for mosquitoes and doesn't seem to think that it affects other insects. We clearly have had a reduction. What other options would you suggest to get him off the gas? Their negative effect on other insects from CO2 vacuum traps.
Okay, that's a different approach. The CO2 vacuum traps, it's not just CO2, there's also octanol in there, which is essentially cow breath. And that is attractive to some species of mosquitoes. I did a study way back in 1996 looking at just those straight bug zappers. They killed 0.02% biting flies. So 99.8% of the kill was non-targets. Oh. But when you add CO2 or octanol, it does draw in mosquitoes much, much better. So that's fine. It's much better on avoiding non-targets. They're expensive, but if you want to go to the trouble, that would work. I would try the dunks. They're cheap and easy, and real mosquito people know you control them in the larval stage, not the adult stage.
Mm-hmm. Smart. From Susan Toramina, how do the caterpillars on vegetables contribute to bird food?
Not that well. We do want to have our vegetable gardens, but our goal with a vegetable garden is to grow food for humans. It's not to support the local biodiversity. And the typical pests of vegetable gardens, not all of them, but many of them, like the cabbage worm, it causes all the problems on those guys. They're introduced insects themselves. So they're here without their natural enemies. Birds will take them a little bit, but everybody knows that birds are not going to control your cabbage worms on your garden.
Yep.
We do have native pests like the tobacco hornworm. What really controls the insects the best in nature are parasitoids, other insects, so little parasitic wasps. And those white cocoons on the back of the tomato hornworm and the tobacco hornworm, those are braconid wasps that have parasitized the caterpillar. So actually you can blend control of your garden with your native plantings around it very well. So for example, at our house, we have 17 species of sphinx moths, and only one of them is the tobacco hornworm. And all the other species support the braconid wasps that control the tobacco hornworm. So if we ever get tobacco hornworm, they get hammered by those braconids right away. Whereas if we had no native plantings around us, we'd have no other sphinx moths. You'd still have the tobacco hornworm, and the braconids wouldn't be here to control it. So I wouldn't plant a vegetable garden to help the birds. I'd plant it to get tomatoes and be able to eat it yourself. So
I'm going to just bounce off that for one moment and ask, is there any one particular microbial life hack that everyone should do? I mean, when I used to work in New York, we would introduce various kinds of nematoids and that sort of thing. That's not my but this was on the advice of specialists. Is there any like this idea of this housewife learned this one neat trick to save the world in that realm, if that makes sense?
Yeah, the trouble is each problem probably has its own unique situation. So there's no one thing you could do that would control these problems. The best way to control these problems is all of these problems are coming from introduced pests, introduced diseases, introduced plants, introduced insects. If we stop introducing them, that's the best way to control these problems. But once they're here, it is. I mean, look at the gypsy moth. Look at the winter moth. Look at the what's the other one you've got up there? The brown-tail moth. I mean, they're all introduced here without their natural enemies. They all cause the emerald ash borer. I mean, these are huge problems that we have created ourselves by releasing these things. They're not evil inherently. They're just here without their natural controls. And there's no one thing we can do for every one of them that will supply the natural controls. That's what biological control is all about, trying to reintroduce the enemies that will keep these guys in control. And sometimes it works really well, but it's hard. Minimum 10 years, even if it's successful. So
plant white oak trees. That's what we're going to say. So one comment, CO2 vacuums this is from Eric Hutchins, the CO2 vacuums will support killing other insects and everything else on the planet by burning more fossil fuel. Just kill a few mosquitoes, no offense intended. Anyway, let's see. Also suggested is supporting bats. What are good plants to support bat species? Do bat boxes even work?
Bat boxes are a place for particular species of bats to roost at night. The biggest problems our bat populations have right now is white nose disease that it had killed off the fantastic numbers of the bats that overwinter in caves. I guess that's the little brown bat or the big brown bat, and several species. But also a reduction in the insects that they eat is a huge problem, not just for bats, but for nighthawks, for whippoorwills. Those guys all live on large moths that fly around at night. So when we reduce the large moth population, you're hurting the bats. Yes, they do eat mosquitoes and they eat other things that are flying around at night, but reducing, so your night light at night is going directly against what that bat wants. The bat wants to fly around and get those insects rather than have them all killed at your light. So plant the plants that make the particularly the moths, that's what they're living off of, and turn out your lights. That's the best way to help bats.
Excellent. Eric asked another topical question that's been duplicated by a few people I've spoken with. You discuss if there's a tangible level of benefit of cutting lawns at a higher cut line, and perhaps if you can talk a little bit about spring and or fall cutback with regards to native perennial gardens in the same at the same time.
Okay. Well, there are benefits to not cutting your lawn as much. All right. So if you leave it higher and cut it less frequently, you are actually, if you cut it less frequently, you're using less gas, and that's a good thing. If you leave it higher, it's better at absorbing rain. It's better at increasing infiltration when you have longer grass. Does it do anything for insect populations? Not really. If you cut it every 3 weeks instead of every 1.5 weeks, you're still going to kill everything on a repeated basis. Plus, it's still a cool season European grass. You're probably still going to fertilize it, which includes a broadleaf herbicide. You don't even know it, that's what eliminates the dandelions and the clover and anything else that might actually help pollinators. So my solution to the lawn issue is to have less lawn. The lawn you keep will still be an unproductive place, but you can make productive areas on your property where there were unproductive. If you take your 5 acres of lawn and mow it less frequently, you're still going to have a biodiversity issue.
From Lucas O'Neill, is there any legislation on the horizon that would stop the selling of foreign plants?
Yes. Delaware just passed a prohibition against selling invasive plants that will go into effect next year. Not only that, it was 100% supported on both sides of the aisle.
Excellent.
Yeah, and it was Senator Stephanie Hansen that pulled that off. We got to get her to be president. I mean, she knows how to work both sides very effectively. And there are Massachusetts has some rules against selling some invasives, and so does Maryland. Oregon has banned the sale of invasive English ivy. The problem is the legislation always comes decades after the plant is hopelessly invasive already. So yes, we should stop selling it, but and that is step one. And every state should have those issues. And you know what? The nursery industry wants that. If you make it voluntary, and one nurseryman says, "Okay, I'm not going to sell burning bush," but the other guy doesn't, and then public goes and buys it no matter where because they don't know, then the guy who with a conscience is at a disadvantage. If there's a law that says nobody can sell it, then it's an easy, even playing field. So that's what they want. And this argument that, you're going to put them out of business is crazy. People buy plants. If we replant 20 million acres of lawn, it's not going to hurt the nursery industry. Believe me, it's what we're doing is saying change your inventory, but they're still going to sell a lot of plants. They don't get a bonus by selling a Chinese plant. Believe me, they can sell native plants. It's simply a matter of re-educating about plant choice.
And can I ask whether have you heard of people working in a mode of not strictly horticulture, but improving ecological function in deeply neglected landscapes? I mean, I'm coming from New York City from the last couple decades, where so much of it is just brownfield, neglected, tough places. And I would always look at it, and sometimes I actually did this myself, which would be to stuff a few rhizomes of Canada goldenrod or something, wildly aggressive of that along those lines. And I feel like we could improve ecological function in the most unlikely places with minimal effort. Have you heard of municipalities working in that mode?
There's a guy at Rutgers, and my senior moment brain, I know him well, but I can't remember his name right now. He may be retired at this point, but he spent the last 20 years of his career working in exactly that, trying to find ways to restore the much of the meadowlands. What works, what doesn't work, where you practically have no soil. He was working in terrible places.
Yeah,
he learned a lot. And if you could, talk to somebody at the Rutgers, I don't even know what department he was in. Anyway, he's done a lot of research on it. And so, yes, there are some people working, but it's not at the level where municipalities are leading the way with the research to do it. We can't even get them to plant in good soil. So we're getting there. We are learning a lot, and a lot of elected officials are moving in the right direction at this point. There's still a lot of research that needs to be done, particularly in terms of reclaiming areas that we've wrecked. I'll tell you one thing though, coal mining, the zillions of acres in Kentucky and West Virginia where the mountaintop leveling, and then they just dump all the stuff in the valleys, then throw some soil on the top and say, okay, that's a restored ecosystem. You've taken a forest and turned it into a grassland. But one of the things they're finding is that the effort to restore the American chestnut, they're working for resistance against the blight, but chestnuts turn out to be really, really tolerant of those mine tailings. And yeah, so they're turning out to be the perfect reforestation tree in a place where they used to be anyway. So that research is going really well. So.
Yeah. Well, Doug, I think you've been incredibly generous with your time and especially with your knowledge. We're so grateful for this talk. And I think, well, I've got one new message. If I'm going to ask you this is the last question under the wire from Larry Simpson. And then we'll let you go. And I really, really appreciate your time. But, how does climate change affect our plant selections? Will these species you recommend continue to grow in Massachusetts if the climate warms 2 degrees Celsius or more?
Yes. There's a lot of people talking about assisted migration. We got to move plants up from the south.
Yeah.
I don't favor that because look what's happening. We're not getting a gradual warming of the planet. We're getting more erratic weather. We still get the polar vortex every winter. And you move southern plants up, they get killed, even though the average temperature is higher. But what we're getting is, more severe droughts, more severe hot spells, more severe cold spells. Look at what happened in Texas in April. They had a deep freeze down into Mexico. So we're not. It's the variability that's clobbering us, rather than a slow, gentle warming where you can move plants all over the place. Plus, if we move plants great distances, you've moved them away from all the interactions that they're generating, that they're there to generate. And then you have a plant, it's just like taking it from China that's not going to do anything. So climate change is a real challenge, but what we want is a lot of genetic variability in our plants so they can adapt themselves. That's called natural selection. And we hope that the plants can do it.
All right. Well, with that, thank you so much, Doug Tallamy. And thank you to the Garden Club folks. I don't know if anyone else needs to chime in or we'll consider the meeting adjourned. I'm new here.
Well, you're welcome anyway. All right.
Yes, thank you very much, Doug. That was really wonderful. I learned a lot.
You're welcome. Have a good weekend, even though it's not the weekend.
You too.
All right. Take care.
All right. Thank you.
Thank you.
Well, that was good.
It was very good. I loved it.
I did too. Let me turn off the recording.
I did too.